Hello and welcome to my YouTube channel, The Concepts of ICT. It's been a long time since I released a video on the concepts of ICT, so I decided to do a lesson on networking because the students find it a bit hard to grasp the concepts. So hope you'd like this video. In this lesson, we are going to discuss about the IP addresses, the concepts of the IP addresses. Before going into IP addresses, first let's discuss about the internet. So what is the internet? The definition of the internet is, we call it a network of networks. So what does that mean? A network of networks? We know simply the internet is spread throughout the world. So network of networks means uh, all the networks which are spread throughout the world are connected through this network to this network to create this network. So simply all the networks around the world is the internet. When we connect all those together, that becomes the internet. So how do we find a machine or a device in this network called the internet? So to identify each of these hosts or devices, we use the IP address. So an IP address, what is an IP address? Hope you have seen an IP address in your computers. Simply it is a 32-bit long address. When we represent it using binary format, it is a 32-bit long address. But usually you see it in decimal format. You get it as 4 decimal digits. We call that notation the dotted decimal notation because there are 4 decimal numbers and each decimal number is separated using a dot. So that is what you have seen. If you have seen an IP address, that is what you have seen as an IP address. So each of these decimal number represents an 8 bits of the IP address. That's how you get 32 bits, 4 decimal numbers. So the smallest number that this decimal number can take is 0, because for 8 bits the smallest value could be 8 zeros, which will create the 0, decimal number 0. The largest number will be 8 ones, which will be simply 255. So each of these decimal number should be between 0 to 255. That is how we get, that is how we identify a valid IP address. Each decimal digit, each decimal number should be between 0 and 255. So that's the basic concepts of the IP addresses. And when we discuss about IP addresses, there are 2 forms actually. The one which we discussed up to now is called the IPv4, IP version 4. The other is IPv6, IP version 6. This is the one that we have discussed up to now, which consists of 32 bits, and in IPv6 you'll find 128 bits. We are still migrating from IPv4 to IPv6. We still use basically the IPv4, but you can find the IPv6 address also for your devices when you are get connected to the internet. Okay, when we discuss about the IP addresses, an IP address consists of 2 main parts. We call them the network portion and the host portion. So all the addresses consist of these 2 parts, the network portion and the host portion. So what are they? Basically, the network portion is used to identify the network the device is in. We discussed that the internet is a network of networks. So you should identify the network before going into identifying the device. So for that, the network portion is used. The network portion of an IP address is used to identify in which network this device is in. Hope you got the concept. And when you go to the network, particular network, to identify the host, the device which sent the message, the host portion is used. Simply when we are writing a letter, when you write the address, you usually put the name of the house or the number of the house, then the street, then the town or the city, then the country. That's how you write an address. So first, when you put that into the post office or when you post that, the first thing they look into is the country. If it is sent to the same country, within the same country, they'll then select the city or the town. It will be sent to that particular town, and when it is sent to that town, within that town they select which house that the mail is sent to. So the same concept is applied in this internet also. First they see which network, then they go to that particular network, and in that network they find the host which sent the message. So that is how the addressing concept takes place within the internet. Hope you got it. And to identify this network portion and host portion, we use a concept called the subnet mask. This is very crucial. You should understand this very well. The subnet mask. So it is used to identify the network portion and the host portion of an IP address. A subnet mask also is a 32-bit long address, and it consists of continuous ones, and after that some bits of zeros, continuous zeros. There cannot be any zeros within the ones of the address, and there cannot be any ones within the zeros of the address. So it is something like this. So there cannot be any zeros within these ones, and there cannot be any ones within these zeros. It should take the form of this. I didn't mean that the number of ones and zeros should be exactly this number, but it should take the form of this. There should be continuous ones and continuous zeros after that. So this is used to identify the network portion and the host portion. So how do we do that? First we get the IP address and we convert that into binary format, and you get something like this. And then you do the bitwise AND operation between these two addresses, the IP address and the subnet mask. For example, let's see this. Let's consider the IP address is this 160.230.15.10. So let's convert that into binary format. So this is what you get when you convert this IP address into binary. Then you perform the bitwise AND operation between these two addresses, the IP address and the subnet mask. We know that to get the output as 1 in binary, that in bitwise AND operation you should get the inputs as 1, both the inputs as 1. If one of the inputs becomes 0, the output will be 0. So AND operation between two ones will be 1 0 1 0 0 0 0 0. So this is how we do the bitwise AND operation, and this is how we obtain the network portion of an IP address. So when we convert this into decimal, that is the network address of this IP address. So what will be the network address? 160.230.0.0. So that is the network portion or the network address of this IP address. If we consider the network portion is 16.230 and the host portion of this IP is after this part, which is 15.10. So the network portion is 160 and 230 and the host is 15.10, 0015.10. So first it discovers this network within the whole world. It finds this network, and when it goes to this network, it goes on finding this particular host. So that is what happens within the internet using this network portion and host portion. So to get the network portion and host portion, we use the subnet mask. So you'll find the subnet mask not in binary format, it also is represented in decimal format. So this subnet mask is something like this: 255 255.0.0. So continuous ones and continuous zeros. Hope you got the concept. And even in this calculation, you don't have to perform the AND operation. When you find 255, which means 8 bits of ones continuously, you get the same value as the network portion for that octet. And here also you get 255, so you get the same value for that particular octet, and that will be the network address of that particular IP address. And if you have zeros, that will become zeros, because when you perform AND operation, we discussed that if one of the bits becomes zero, the output will also be zero. So these two octets will be zero. Okay, good. Hope you understood the concept up to now. Okay, when we discuss about the IP addresses, there's a concept called the IP address class. There are 5 main IP address classes. We call them A, B, C, D, and E. In the internet, for the hosts, we use only the A, B, and C classes, and D, E classes are reserved for future use and for research purposes. And to identify a class of an IP address, we use the first octet of the IP address. That is what we use, only the first octet. It will determine which class this IP address belongs to. So let's see the IP address classes and how we identify the class of an IP address. Okay, we will discuss about the classes using this table. So I explained that we determine the class of an IP address using only the first octet of the IP. So there are 5 classes. The class A, in the class A IP addresses, the first octet arrangement is something like this. In the first octet, the first bit should be 0 in class A IP addresses. It is a constant. It cannot be changed. The first bit will be always 0 in class A IP addresses. So that is the arrangement of the first octet, the bit arrangement, and the range then will be, the smallest value that this can take is 7 zeros after this, and the largest value could be 7 ones for these 7 bits. So what will be the value range then? 8 zeros means including the first bit, that will represent the value 0, and the first bit 0 and 7 ones will be 127. So that will be the range. And for the class A IPs, the default subnet mask will be 255.0.0.0. So how many networks are there? When you consider the subnet mask, that we know that we identify the network portion and IP address using the subnet mask. When you consider the subnet mask, default subnet mask, the network portion comes only within the first octet, because we have 255, then zeros, three zeros, three octets of zeros. So only the first octet represents the network portion. So there are 8 bits in the first octet, but the first bit is a constant, which is 0. Then the next 7 bits can be changed to create different network addresses. So how many networks can be created using this? Using 7 bits, you can create 2 to the power 7 different networks, different arrangements, which means different networks. So the number of networks will be 128. 2 to the power 7 means 128. So the number of hosts, the host portion is this part, the last 3 octets. So different hosts will be 2 to the power, there are altogether 24 bits, and 2 to the power 24. But there is a little problem actually. The first address of the network, the first host address of the network, each is called the network address of that particular network, and the last address of the address range is called the broadcasting address. These two addresses cannot be assigned to hosts or the nodes, so it should be subtracted from this number of hosts, minus 2. Hope you got the idea. The network address and the broadcasting address cannot be assigned to hosts. Okay, then the class B. In class B IP addresses, the arrangement of the first octet is something like this. The first 2 bits should be 1 and 0. Then after that you can take any value for the remaining 6 bits. So the value range will be 6 zeros, which is 128, up to 6 ones, which is 191. The default subnet mask for the class B IP addresses is 255.255.0.0. So the network portion is in the first 2 octets. So how many different networks can we create? So there are altogether 16 bits in the network portion, but the first 2 bits is a constant, 1 and 0, it cannot be changed. The remaining 14 bits you can change them to create different network addresses. So how many different networks can you create? 2 to the power 14. In the host portion, how many bits are there? Last 2 octets, which will be 16 bits. So how many different host addresses you can create? 2 to the power 16, and don't forget minus 2. Okay, that is the class B. Now let's consider class C. So class C, the first octet bit arrangement is something like this. The first 3 bits will be constant, 1 1 0. Then after that you can have anything. So then the value range of the first octet will be 5 zeros will be 192, up to, when you have 5 ones here, it will be 223. So the default subnet mask will be 255, 255, 255 and 0. So there are altogether 3 octets for the network portion, and the last octet will be used for the host addresses. So how many different networks can be created using this? The first 3 bits is a constant, then remaining how many bits? there are 3 octets, which means 24 bits, and you can't use the first 3 bits for the network addresses. So there are 21 bits, so you can create 2 to the power 21 different network addresses. Host portion is the last 8 bits, so you can create 2 to the power 8 different addresses, and you can't use the last and the first addresses, so that you have to subtract 2 addresses out of that range. So this is the basic of the classes, IP addresses classes, and there are classes D and E, but we don't use them in the internet for the host addresses. Class D arrangement will be something like this. So the value ranges will be, we are going to use the subnet masks because we are not going to assign them into networks. So there's no need to identify the network portion and host portion. So that is the basic of the class full IP addresses, or the classes of the IP addresses. Okay, good. So in this lesson we discussed about the basics of the IP addresses. We discussed what is an IP address, the arrangement of an IP address. Then we discussed that there are 2 parts of the IP address, as the network portion and the host portion. Then we discussed how to identify this part, these two parts, the network portion and host portion, using the subnet mask. So in that part we discussed what is a subnet mask and how to identify a valid subnet mask. Then we came into the classes of IP addresses. There are 5 classes, but we use only the first 3 classes. Then we discussed how to identify the classes of the IP address. We discussed that we use only the first octet of the IP address to identify the class, and through that we discussed how many networks can be created in each class and how many host addresses are there in each class. So that is the summary of this today's lesson. Hope you understand everything, hope you learned everything. If you have any questions on this lesson, you can use the comment section. And in the next lesson I'm hoping to do some more about the IP addresses, and to discuss about the concept called subnetting. And keep this channel subscribed. uh, you can learn more about the concepts of ICT in my future lessons as well. So if you want to learn about my previous lessons, there are a lesson series on the number systems, the logic gates, and there are some lessons on ER diagrams and context diagrams. You can go and watch them as well. So please do subscribe my channel, and see you on the next lesson. Thank you.